Hello everybody, welcome to a review in College Algebra. There is a timestamp in the description, so if you want to go to any particular prompt, just click on the link in the description. Alright, so first we'll give the subset of real numbers from this list. So the first question, we want to find the integers. So integers, we'll get there in a minute, but first we have the natural numbers. Natural numbers are counting numbers. So in this set, we're going to have 18 and square root of 16. So those are natural numbers. And then after that, we will include the 0. That will be whole numbers. So will be 18 square root of 16, which is 4, and then the number 0. And then we go to integers. Integers will be pretty much all the numbers we have here, except they could be also have negative. They can be negative as well. So on this list we have negative 17. So integers are the set of those numbers. Right. Next, rational numbers. I'm not going to do like this again, but pretty much we're going to list anything that can be written as a ratio. We include the natural numbers, the whole numbers, integers, and then we add the ratios as well. So the rational numbers, timestamps. Rational numbers. Right. 14, it is the natural numbers, whole number, and certainly will be rational. So 14. Square root of 8, it is irrational because square root of 8 is not a natural numbers. Negative 8 is good. 0 is good. A ratio certainly good. Square root of 9 is 3, which is good. Repeating decimal, which is also good. Terminated decimal, which is also good. So we have all of this except for square root of 8. So remember, in general, if we take the square root of the natural numbers, there's only two possibilities. It could be a natural number, or if it's not natural numbers, it must be irrational. Since square root of 8 is not natural, it has to be irrational. So just list everything else other than square root of 8. Right. Next we solve this equation. Right. I'll use factoring and then quadratic formula. You only need to do one. You can choose completing square as well. Right. Factoring, we'll take the first. We'll find two numbers multiplied together equal the first times the last. The first, I just write first times last. First is 1, last is negative 45. So that is 1 times negative 45 is negative 45. And then those same two numbers must add up to the middle one. Middle coefficient is 4. Right, and then we just guess them. I should say trial and error. Negative 45. So we could have 1 and 45. Or 1 and negative 45. That doesn't work. 2 doesn't work. 3 and 15. Negative, positive, or positive, negative. Right, so that doesn't work either. and then 4 doesn't. So go to 5 and 9. I have to choose one to be positive, one negative, right? So that's good. Negative 5 and 9, those two numbers multiply together is negative 45, and add up together equal to 4. So we have negative 5 and 9. So we start with x squared plus 4x minus 45 equal to 0. I will split the middle term into negative 5x plus 9x minus 45 equal to 0, x squared. Right. Then we can factor. Let's group the first two and the last two. The first two have x in common. Factor it out. We have x minus 5. The other two, I can factor out 9. Then also x minus 5. There's a plus. Both x minus 5 in common. We factor it out. We left with x plus 9. Right, next. Two factors multiply together equal to 0. One of them, at least one of them must be 0. So we have x plus 5 on both sides and minus 9 on both sides. So we have 5 and 9. So that is using factoring method. Here I also use quadratic formula. You only need to do one. Right. A is 1, B is 4, and C is negative 45. Right. Put everything in that formula. Negative 4 plus or minus b squared minus 4 c over 2a. Right. So we have negative 4 plus or minus 4 squared 16. 4 times 45, that's 180 over 2. So we have negative 4 plus or minus 16, 180 is 196. Square of 196 is 14. So we have negative 4 plus 14 over 2, and negative 4 minus 14 over 2. That gives us 10 over 2, which is 5, and negative 18 over 2, which is negative 9. So we have 5 and negative 9. Right. Next, radical equation. For radical equation, we need to have the square root by itself. So first thing, I'm going to add 8 on both sides. And then we have x plus 8. Right. Next, we will square both sides. When we do that, we check the solution. Square cancel square root. So we have 28x plus 28. X plus 8 square, just x plus 8 times x plus 8. Multiply them out, x square plus ax and 64. save this part to check the answer over there. Right, 20x plus 28 on the left hand side. Right, combine like terms here, ax and ax, that 16x. I'll move everything on one side. So we should have x squared minus 12x 64 20. That looks like 6. Right, equal to 0. So pretty much we have x squared minus 12x plus 36 equal to 0. Alright, that is actually a perfect square. Anyway, I'm going to use a quadratic formula because it's usually factoring. Sometimes we have to trial and error. This could go very long. Quadratic formula is pretty much there's no guessing. We just plug and check. Right. So A is 1, B is negative 12, and C is 36. Negative 12 plus or minus B square negative 12 square minus 4 A C over 2 times 1, right, equal to 12 plus or minus 12 square. That is 144, also 144. I retest that. So plus minus 0 is still 0. So we just have 12 over 2, which is 6. So just one value, still need to check. Right, so 28 times 6 plus 28 minus 8, is that equal to 6? Right, I actually have a calculator here. Right, we have square root of 28 times 6 plus 28, so that's 14 minus 8 equal to 6, so that check. So the solution, we only have one of them, x equal to 6. Right, so that is that. We have another one of those. Right, same thing. We try to get the square root by itself, so I can minus x on both sides. So we have minus square root of 3x minus 2, and then minus x plus 4. Right, we can square both sides right now, but it will be better we just get rid of that negative, so we divide by negative 1 on both sides. So we have square root of 3x minus 2 equal to negative x divided by negative 1 is x. 4 divided by negative 1 is negative 4. Right. Only then we square both sides. When we do that, make sure we check. Right. Of course, square both sides. Square cancel the square root. We have 3x minus 2 equal to x minus 4 square. X minus 4 square is multiplied by itself. I just say x minus 4 here. Right. Now we multiply it out. 3x minus 2 stay the same. X squared minus 4x minus another 4x and plus 16. Right. So this is going to be quadratic. We're going to move everything on one side because x squared quadratic equation, we should have 0 on one side. It is easier to do that way. So minus 3x and plus 2. So we have 0 on the left side. X squared minus 4 minus 4 minus 3, that minus 11x and plus 18. Right. That is a quadratic equation. So I use quadratic formula even though I can easily factor. Right. Negative b, a is 1, b is negative 11, c is 18. So b is negative 11 plus or minus square root of negative 11 square minus 4, 1 and 18 over 2a. Right. 11 square 11 square is 121. 4, 18, that's 72 over 2. So we have 11 plus or minus 121 minus 72, 949 square 49 divided by 2. Right. So we have the 11 plus square 49, which is 7 divided by 2, or we could also have the minus. The plus give us 18 over 2, which is 9, and the minus give us 4 over 2, which is 2. Right. Now we check. At x equal to 9, we have x equal to 9 minus 3 times 9 minus 2 equal to 4. That is 9. 27 minus 2 is 25. Square of 25 is 5 equal to 4. So that's good. And then we check for x equal to 2. 2 minus square root of 3 times 2 minus 2 equal to 4. 2 minus 6 minus 2, so 2 minus 2 equal to 4. Actually, that doesn't, obviously that doesn't work. So we only have one solution, x equal to 9. So this is the solution. Next we have the rational equations. Equation that has the rational exponents. Right. So first I try to get that rational exponent term by itself, and then I write in the radical form. X plus 6. Remember this formula, something raised to the m over n, powers on top, root at the bottom. So we have 3 on top, root at the bottom. Right. So now to get rid of the root, we use the power. To get rid of the power, we use the root. So to get rid of the square root, we will square both sides. Square cancel the square root. So we have the x plus 6 cubed equal to a squared, which is 64. Right. Next, to get rid of the cube, we take the cube root. Notice that if this is a square root, there must be a plus or minus on both sides. But since this is the cube root, we cannot put a plus or minus here. So just the cube root, that's it. And the cube root cancel the cube. We have x plus 6. The cube root of 64 is 4. By the way, if you want to use the calculator, the cube root is under math, option number 4. Yep. Right. And then minus 6 on both sides. We have x equal to 2. Negative 2, that is. Right. Just one thing we forgot. Remember, every time we square both sides, we have to check the answer. So on this one, we definitely have to check, because we raise both sides to an even power. Always have to check. So at x equal to negative 2, I'll put negative 2 in for x. Is that equal to 8? Right, let's see. Oops, sorry. Wrong. This one. Negative 2 plus 6 to the 3/2. Yes, 8. Yeah. So we have x equal to negative 2 is the answer. Right. Next, also another one, kind of the same. We'll try to get the rational exponent by itself. So we plus 6 on both sides. So we have 4x minus 5 to the 1/3 equal to 2. Next, we will rewrite the 1/3 power. Power on the top, root at the bottom. And to get rid of the cube root, we will raise both sides to the third power. Unlike this one, when we raise both sides to an even power, we need to check. This time it is the third power, so we don't need to check. That cancel out. So we have 4x minus 5. 2 cube is 8. And then we'll plus 5 on both sides. We have 4x. For x equal to 13 over 4. We don't need to check, so that's just our answer. 13 over 4. The next 3 problems, absolute values equation. So this one has the equal sign, this one has the less than, and this one has the greater than or equal to. Right. So equal to first. So, but on the right hand side must be a positive number. So here we have 5, which is good. The next one, 4, and then maybe this one too. Right. We'll see. Right. X plus 2 equal to 5. Absolute values of x plus 2 equal to 5. So absolute values equal to 5, meaning that it is the distance from 0 will be 5. So we might have negative 5. We may have 5. Also we say x plus 2 equal to the negative number, or x plus 2 equal to a positive number. So that's where we have the absolute values equation. Minus 2 on both sides, we have x equal to negative 7, and minus 2 on both sides, we have x equal to positive 3. So we have 2 solutions, negative 7 and 3. Now we have greater than or less than. This is less than. Absolute values, if it is 4, so we could have negative 4 or 4. But this is less than. If it's less than, the distance to 0 have to be less than 4. So less than will be in between. So we will say that x plus 6 will be in between a positive and a negative. And I will just solve for x. Minus 6. So we have from negative 10 to negative, here with negative 10x and negative 2. So if we draw that, it will be from negative 10 to negative 2, and in the middle, but not equal to. So from negative 10 to negative 2. Right. Next, it is greater than. But before that, we need to get the absolute value by itself. So I will minus 8 on both sides. So 1 minus x over 2 greater than or equal to 2. Right. Now if it is greater than, absolute value is 2 though. So we might have negative 2 to 2. This time it is greater than, meaning the distance have to be greater than, will be on. See if this color works. Be on that side or on that side. So pretty much we will have 1 minus x over 2 less than negative 2. Actually it has the equal sign too. Or we have 1 minus x over 2 have to be greater than or equal to 2. So pretty much it's going to be greater than 2 and less than negative 2. Less than the negative, greater than the positive on the outside. And then we just solve for x. So negative x over 2 less than or equal to negative 3. And then multiply by 2 on both sides. If I multiply by negative 2 on both sides, remember, multiply by negative number, inequality is reversed. That gives us x greater than or equal to 6. On this side, now we multiply by negative 2. Again, multiply by negative number, inequality is reversed. And 1 times negative 2 is negative 2. So we have from less than negative 2 and greater than or equal to 6. And it has the equal sign as well, so it should be the bracket. If we write that negative infinity to negative 2 bracket union 6 to infinity parentheses. Right. Next, give the domain and range of the relation. So this is pretty simple. The domain is the first component, the range is the second component. So the domain, the first component, even though it appears twice, we only need to write them once. 6, 10, and 9. The range. Seven, negative 8, 6, and 2. This would not be a function because we have 9 give 6 and 9 give 2. So it didn't ask for that. It didn't ask for it, but this is not a function. On this question, we only need to state the domain and range. Right. Next, determine the domain and range of this function. So the function go like this. So pretty much it will go as far as we want on the right and as far up as we would like. So the domain by default will be all the x values. We go from this point on, so meaning from 0 on to infinity, including the point. The range, so the domain is all the x values here, and the range we have all the y values from this point on. so from 2 to infinity. And so all the y values from 2 up, including 2, are the range, and from 0, including 0 to the right, is the domain. Determine whether this function y is a function of x. So y is a function of x, but when we say like that, we mean x in the domain and y is in the range. So this is in the domain and y in the range. So to do that, I'm going to solve for y minus x on both sides. We have y squared equal to 4 minus x. And to get back to y, we take the square root. Remember, every time we take the square root or any even root, we have to have a plus or minus on one side. So we will have, I will have y equal to plus or minus, that cancel, square root of 4 minus x. So pretty much here what I have is one x values give us a positive square root and y equal to a negative square root. So it cannot be a function because one x value gives us two y values, so it's not a function. Right. Next we have an even and odd function. Let me write the definition first. F of negative x equal to f of x. If that is the case, the function is even. F of negative x equal to negative f of x. That's where the function is odd. Right. So we always start with f of negative x. So I put negative x into x. Negative x cubed will be negative x cubed. That gives us a plus 5x. Now, compared to the original function, they are not the same. So we say not even. Next, we're going to factor out the minus and see what inside. If we factor out the minus, we should have x cubed, because here's the plus. We should have the minus 5x, because when we multiply it back out, minus minus turn to a plus. Now, what we see is that inside is f of x. So this equal to negative f of x. So f of negative x equal negative f of x. So which means the function is odd. Right. Next. We start with f of negative x again. So we have negative x cubed minus negative x squared, right? Negative 3 times, so still negative. And then that's still negative. because there are 3 negative signs here. Right. So compared to the original function, they're not the same. So it's not even. Now let's just factor out the minus and see what happened. If we factor out the minus sign, we should have the x cubed plus x squared. Now that is not the same as the original function. So this is not equal to f of x. Because of that, it's not odd. If it's not even and not odd, it must be neither. Right. Next we have a function is increasing or decreasing or constant. Right. The function is increasing, so pretty much where it's going up. So here and here. So obviously it's easy to see where it's increasing. However, when we write the answer, it's always is an open interval of x. So identify the open interval of x. The answer always like that. So here we see that for this part of the graph, x go between -2 to -1, and it's always an open interval. And then here we go from 3 to infinity. I just write the comma here. So that's where the function is increasing. Right. Identify any relative max and relative mean. So this point compared to the point, this point compared to the point around it is the highest point. So that gives us the local max. And the coordinate will be x equal to 0, y equal to 1. This will give us, we specify the point. And this is the mean, I should say relative, which is the same as local. So relative mean, x equal to 2 and y equal to -3. So this will give the point x equal to 2, y equal to -3. This x go from -2 to -1. This only have x. This x and y. Right. Piecewise function. So this is pretty simple. So we evaluate a function when x equal to 1. So we identify which one is where we put in 1 is true. So if we put 1 in here, the top will be false. But if we put 1 at the bottom, it is true. So we use this bottom part of the function. So f of 1, we use 2x plus 3, but x is equal to 1. Yeah. Because when put 1 in here, the equation is true. So that's all we have. Right. Now, square, right? Just sketching. X square look like that. Not exactly like that, but close. So inside left and right horizontally, outside up and down vertically, right? And then finally always inside and then outside. So we move everything 3 units to the right and then 4 units up. So that is the final graph. Right. Next, first graph, the absolute values. First graph, the absolute values, which is V. And then we do the transformation. So we have the -2, which is 2 units to the right, plus 5 units up, and 1/3. We'll multiply the y values by 3. Right. So it's always inside and out. So inside and then outside. On the outside, multiply and divide first, and then add or subtract. So this is order of operation. First we move this 2 units to the right. That V. And then y multiplied by 3. I'm sorry. I don't know why I write that by 1/3. Meaning that whatever the height is, we cut that down to 1/3. Whatever the height is, cut down to 1/3. This height, cut down to 1/3. And then just move up 5 units. 1, 2, 3, 4, 5. Remember, the idea is this is not to draw the perfect graph. The idea is this is the transformation. So as long as we have the right transformation and the order of transformation, that's all we worry about. Right. The next transformation. So we are given this function, and then we apply the negative, +2 and +1. Right. +2. That is 2 units. It's inside, so 2 units to the left. And then +1 on the outside. 1 unit up. And the negative on the outside, so it will be a reflection. Reflection on the outside, so it will be vertically. Right. So order operation, once again, inside and out. So +2, 2 units to the left first, and then multiply by negative or +1. Always multiply first, then add or subtract. So first move this 2 units to the left. everything 2 units to the left. And then flip it upside down. So if we go 4 up, we go 4 down. Notice now we just focus on the graph. We just draw, ignore the original graph. This point 4 up, 4 down, and we have that graph. And finally, just move everything up 1 unit. And that's what we have. So that's what we have. Next we will have difference quotient. That formula. So difference quotient, we start with that formula. So we have f of x plus h. We start with the function though. The function is something of something is 3 times whatever that is minus 7. So now if we have x plus h, we're going to have x plus h. So pretty much just that. So that will give us 3x plus h minus 7. So that f of x plus h minus f of x, which is original function 3x minus 7, all of which over h. So now we just simplify, multiply it out, 3x, 3h minus 7 minus 3x plus 7 over h. We see that the 3x and 3x cancel out, the 7 cancel the 7. We only have 3h over 3. I'm sorry, 3h over h, where the h cancel out, we live with 3. Right. Next, another different quotient, but this time for that function. Let's start with the formula first. So we have f of x plus h. So the original function, the function of something, is that thing square, that thing minus 9. Doesn't matter what it is. It just happens to be x plus h. So first we have this. Subtract f of x. This is the original function. Of that over h. X plus h squared, I will just write like this. Here I multiplied out ax and ah minus 9 minus x squared minus ax minus a negative. Right. Now, Of course, we see the negative 9 and 9 here cancel. The ax and negative ax cancel. But we'll do that in the next step. Here we're just multiplying it out. X times x, x squared, x times h. So we have hx, hx, and then h squared, ax, ah minus 9 minus x squared minus ax plus 9. Alright, let's see what we can simplify here. X squared, negative x squared, that's good. Ax, negative ax, and then the negative 9 plus 9. Right, so that's what we're left with. Here we have 2hx h squared and ah. Right, now all of them will have an h on the top, so we'll factor out, left with 2x plus h plus 8, and that cancel out. We left with 2x plus h plus 8. So on these two problems, what we see is that there's some common things, two common steps. The first step is everything that does not have an h in it will cancel out. See, x squared have no h, should cancel with something. Ax doesn't have an h in it, should cancel with something. And the negative 9 should cancel with something. So cancel everything without an h. That's the first step. The second step is we cancel with the h at the bottom. Usually we should have those two steps. Right. That's all for this review. I hope you found this helpful. Thank you for watching.